Good day, students. Now it is the seventh lesson, named the mode and the median of the continuous random variable. Right. The mode and the median of the continuous random variable. First, give the definition of the mode. Mode is such value of the continuous random variable at which the distributive density has the greatest value. It is the mode. Right. The mode is such a value of the continuous random variable at which the distributive density has the greatest maximal value, or the maximal value. It is the definition of the mode. Then consider the definition of the median of continuous random variable. The median is such a value of the continuous random variable A, for which integrals from minus infinity to a and from a to plus infinity of the distributive density are they equal, for which integral from minus infinity to a f of x dx is equal to the definite integral from a to plus infinity of x dx. Then a will be the median. It is median. The notation of median is ME. It is the notation of median, and the notation of mode is MO. Mode. And then we will show that each of these integrals is 1 second. Now remember the definition of median of the continuous random variable, and the basic probabilistic equality. Integral from minus infinity to a f of x dx is equal to the integral from a to plus infinity f of x dx. It is the condition of the median, definition of median, definition of median, and then write the basic probabilistic equality. Integral from minus infinity to plus infinity f of x dx is unit. It is the basic probabilistic equality. Rewrite, then separate the integral of the basic probabilistic equality into two integrals from minus infinity to a and plus integral from a to plus infinity. Integral from minus infinity to a of f of x dx plus integral from a to plus infinity of f of x dx is unit. And according to the definition of median, this integral is equal to this integral. And rewrite the last equality. Integral from a plus to plus infinity f of x dx plus again integral from a to plus infinity f of x dx is unit. Two integrals, twice integral from a to plus infinity f of x dx is unit, and therefore we will obtain that integral from a to plus infinity f of x dx is 1 second. And also the integral, if this integral 1 second, then use this equality, integral from minus infinity, and also according to the definition of the median, this integral is equal to the integral from minus infinity to a. Therefore, we will have that integral from minus infinity to a f of x dx is also 1 second. 1 second. And these formulas are used for the finding the median of the continuous random variable. It is first rule for finding the median. It is the second method of the second method for the finding the median of the continuous random variable. Also, we can rewrite the formulas for the finding the median of the continuous random variable. Remember that the probability that the continuous random, the value of continuous random variable will belong to the interval AB is defined by the following formula. P capital of P capital that A is less than X is less than B equals the integral from A to B f of x dx. It is the probability. And then write the two formulas for the median finding. Integral from A to plus infinity f of x dx is 1 second, and integral from minus infinity to A f of x dx equals 1 second. 1 second. Then it is probability that the value of continuous random variable will belong to the interval from A to plus infinity. A is less than X is less than plus infinity is equal to 1 second. And P of minus infinity is less than X is less than A is equal to 1 second. Or we can write the last record in the following form. Integral P for X is greater than A is equal to 1 second, and P for X is less than A is 1 second. Here A is median according to the definition. Therefore, we can write P for X is greater than median is equal to 1 second, and P of X is less than median is 1 second. It is the condition. It is the condition of the median for the continuous random variable. Then consider the following theorem. If the distributive density is a symmetric function with respect to A, where A is symmetry center, then median of the corresponding continuous random variable is equal to the symmetry center. Write the median of continuous random variable the median of continuous random variable with the symmetric distributive density. Distributive density. If distributive density is a symmetric function, that is, if f of a minus x is equal to f of a plus x, here a is symmetry center, then the median of continuous random variable is equal to A. That is, median is equal to the symmetry point. And we must prove this formula. Prove this formula. Now consider the proof of the given theorem. Proof. Let the function f of x, that is distributive density, is the symmetry function with respect to point A. Name the symmetry point. Then if f of a minus x is equal to f of a plus x, that is, if A is symmetry point, then median of the corresponding continuous random variable is equal to the symmetry point. Then median is equal to A. It is median. A is symmetry center. Consider of one of formulas for the median finding. Consider the integral from minus infinity to a of f of x dx. If and let the A is a symmetry center, then we must prove that median is equal to A. That A is a median. Here, let's make the first change and change x by a minus t. It is first change. X is a minus t. X is equal to a minus t. Then t is a minus x. From here, dx is minus dt. Also, we must change the integral limits for the variable x, and we must obtain the integral limits for the new variable t. Here, lower integral limit is minus infinity for x, and for x the upper integral limit is a. If x is minus infinity, then t is equal to, it is formula for t. If x is minus infinity, a minus infinity is plus infinity, a plus infinity is infinity, because if add the constant number to plus or minus infinity, then plus or minus infinity will be kept, will be retained. Therefore, it is t is plus infinity. And if x is a, substitute a instead of x in this formula, and we will obtain t is equal to 0. Then use this first change in for this integral. Integral from plus infinity to 0, f of a minus t multiplied by minus dt. Here we can take a negative sign out of the integral symbol equals minus integral from plus infinity to 0 of a minus t dt. Then change places the integral limits. You know that if change the place of integral limit, then the defined integral will change on sign. Therefore, we will obtain plus integral from 0 to plus infinity of f of a minus t dt equals. Then use the indication of the symmetry of the function symmetry with respect to a. We can change f of a minus t by f of a plus t. F of a plus t. To plus infinity, f of a plus t dt. Then again return to the x variable. Let use a second change, and let's change a plus t by x. Now it is x. Second change. X is a plus t. Then t, from here t is x minus a, and dt is simply dx. Here we must also change the integral limits, because these integral limits are given for the variable t, for the t variable, and must find the integral limits for the x, new variable x. If t is 0, then x is a plus 0 is a, x is a. And if t is plus infinity, then substitute plus infinity instead of t, a plus infinity is also infinity, x is plus infinity. And use the second change in the last integral from a to plus infinity f of x dx. We already proved that integral from minus to a of f of x dx is equal to the integral from a to plus infinity of f of x dx. It means here a is median. That is, median is equal to the symmetry center. Already we proved this theorem. Now go to the examples on median of the continuous random variable, finding the median. Example 1. The continuous random variable, is given by the distributive density, by the following distributed density. Following distributed density. Density. F of x is equal to x in the interval uh, 0, 1 and 0 outside this interval, outside this interval. This interval. Find the median. Find the median. Find the median. Median of continuous random variable. The given continuous random variable. Of continuous random variable. Random variable. Solution. Here we have three intervals from minus infinity to 0, from 0 to 1, and from 1 to plus infinity. In the extreme intervals, our function is 0, but in the middle interval is 2x. Construct these intervals to plus infinity, 0, 1. Here f of x is 0, then f of x is 2x, and here f of x is again is 0. Then we can find the median by two methods with the help of the one of two formulas. First, use the first formula. First formula is integral from a to plus infinity f of x dx. Dx is 1 second. Here from a and also you must remember that the median belongs to the interval in which our function is different from 0. It means here a must belong to interval 0, 1. And remember that median must belong to interval AB. It means A is situated between 0 and 1. They construct intervals for the first case. Interval from 0 to 1, and A is situated between them. Rewrite these records. F of x is 0, f of x is 2x, f of x is 0. And here integration is held from a to plus infinity. From a to plus infinity. And now we have only two intervals, from a to 1 and from 1 to plus infinity. Integral from a to 1, f of x dx plus integral from 1 to plus infinity f of x dx is 1 second. 1 second. In the first interval, the interval from a to a belongs to the interval from 0 to 1, in which f of x is 2x. Here we can change f of x by 2x. In this interval, f of x is 0. F of x is 0. And every integral of 0 is also 0. Therefore, we have only one integral. Integral from a to 1 of 2x dx is 1 second. 1 second. Here integrand is 2x and its antiderivative is x squared. X squared with double substitution from a to 1, a to 1 is equal to 1 second. They first substitute 1 instead of x, subtract, then substitute a instead of x. 1 squared minus a squared is 1 second. Here a squared is 1 second, a squared is 1 second, and a is plus or minus 1 over square root of 2. It is approximately square root of 2 is approximately 1.4, and therefore 1 over 1.4 is approximately 0.7. 0.7, and therefore is plus or minus 0.7. Positive 0.7 belongs to the interval 0, 1, but minus 0.7 doesn't belong to this interval. Therefore, we have for a only one value equals 1 over square root of 2. A is equal to 1 over square root of 2. It is the answer for median. It was the first method. Now go to the second method. Then use the second method for finding the median. Second method, use the second formula for median. Integral from minus infinity to a f of x dx is 1 second, and here we must find the value of a. Again construct the intervals, but now for the second integral. It is the real axis from minus infinity to plus infinity. 0, 1, a. We had three intervals. In the left interval f of x is 0 according to the condition. In the middle interval f of x is 2x according to condition, and in the right interval f of x again is 0. And here the integration is held from minus infinity to a. And now we have two integration intervals, and therefore we can rewrite this integral as the sum of two integrals. The first integral is taken from minus infinity to 0, and second integral will be taken from 0 to a. Integral from minus infinity to 0 f of x dx plus integral from 0 to a f of x dx is 1 second. In the interval from minus infinity to 0, our function is 0, and definite integral of 0 is also 0. And interval from 0 to a belongs to the interval from 0 to 1, in which f of x is 2x. And therefore we can change f of x by 2x. And finally we have only one integral from 0 to a of 2x dx equals 1 second. Then here the integrand is 2x, and its antiderivative is x squared. X squared with double substitution from 0 to a is 1 second. And first substitute a instead of x, then 0 substitute from instead of x. A squared minus 0 squared is 1 second, and a squared is 1 second, and a is plus or minus 1 over square root of 2, and it is approximately equals to plus or minus 0.7. The value plus 0.7 belongs to the interval 0, 1, but another value minus 0.7 doesn't belong to this interval. Therefore, we have only one value for the median. And here also we obtain the same result. A is 1 over square root of t. It is our median. It is answer. And here the value of the median is verified. Finally, please rewrite your homework assignments. Homework. Example 1. The random variable, the continuous random variable, continuous random variable is given by the distributive density, by the following distributive density. Distributive density f of x is equal to x plus 1 second. 1 second is interval 0, 1 in 0, 1 and 0 outside this interval, Find the median. Find the median. continuous random variable. Of the continuous random variable. Random variable. And second example. Here f of x is f of x is equal to 24 over x to 4 for x is greater than or equal to 2, and 0 for x is less than 2. Here also find the median. Now our lesson ended. Thank you for your attention. Good luck. Goodbye, students.